My name is Dan Blanchette, and I am a PhD student here at the University of Idaho, Coeur. In my off time, I love playing board games with friends and family, hiking and kayaking the lake. So I'm a PhD student currently at the University of Idaho, Coeur up here. I got into computer science through the NIC 2+2 program, where you start as undergrad student for 2 years at NIC, you come and you finish your bachelor's degree. And at that point, I was really loving what the robotics program offered up here. In fact, I honed more into the automation side, which is things that control conveyor belts and sensors on factory lines, and trying to figure out, at least at this stage in my PhD, how we can apply explainable AI methods and techniques to help people that are within the industry figure out common problems or forecast negatively impacting events that affect their production and workflow. So my project is with the Inland Empire Paper Company. What we're trying to do right now is basically find a forecasting model that is going to be explainable to them in their process. In doing so, we're looking upstream of the wastewater facility so they can maintain compliance for discharge in the Spokane River. So we're looking at the pulp mill and we're looking at the paper machine as potential culprits for what's going on in terms of the chemical flow coming into the plant, and seeing if we can give them some early warning indications that a negatively impacting event could potentially be shutting down or stalling their process, or basically breaking that compliance. This project kind of comes from a mutual relationship between myself and my major professor, Dr. Shelvick. Typically, as a grad student, you want to do something that interests you, and that's one of the criteria that Dr. Shelvick maintains with his students, is that you have to be interested in the project. He also has to be interested in the project as well. So there's sort of this mutual exclusivity of trying to find a good match with an industry partner and something that matters to both the student and the major professor. So this sort of landed in my lap, more or less from internship that I had, where I'm actually working with wastewater and well systems already at WPD Consulting. And because of my experience with that, I was a better fit for this research partner of sorts to come in and see if we could find a common solution to their problem. So we're taking a very explainable approach. Explainable AI is something that we are typically geared toward at the center, as opposed to using large language models like your ChatGPT or Copilot. Those are very good at doing pattern recognition, but not so good about the thinking. We want something that helps with statistical analysis of large data to help make improved predictions and outlooks for the actual company themselves. And in doing so, we can give them early warning detection and things that way. So things like decision trees or long short-term memory models work together in comparison or in conjunction with one another to actually look at what would be a weather forecasting event to a meteorologist, where the computer's saying, hey, based on the historical data we have for the area and the current state of what's going on in the weather, this is likely to be the weather tomorrow, but you still need the meteorologist at the end making the call, and that's what our decision tree does. It helps look at the results from the prediction and see if they adhere to the standards of the plant or break those conventions and may have an actual negative impact coming in toward the plant at that point in time. So at this point in the project, we're in the preliminary stages. So we're looking at the plant's data and we're trying to figure out which sensors and components really matter to the project. The end goal would be to have a deployed computer at an operator station that's able to give them intuitive results that they can then correspond with their traditional jobs. So if, for example, the wastewater treatment facility is expected to have an event, we want to give them as much time downstream as possible to let them curtail that what people don't realize is with water reclamation systems is it's like steering a really big boat. So any changes you make to the process before that portion take a long time to actually get done. And then once they're at that moment, they have a limited time to actually curtail that. So the plant right now is at a reactive state where they will see an event based on their instrumentation, and then in real time they're trying to adjust that, and that can take hours to get back into compliance. What we're offering them is early warning heads up where they have a couple hours at this point, or better, to try to help them look at those events, get a preliminary event preemption, and say, hey, likely culprit might be these guys upstream, and if you adjust these values that are currently set here, you might have a chance of actually stopping the event before it gets started, or at least minimizing the downtime.